So let's talk about JavaScript. Okay. So JavaScript, right, is considered to be the programming language of the web, right? And that's where it had its beginning, right? It's when Netscape uh, when it took the simple browser and realized that there's only so much that you can do with HTML, right? It's HTML is just ASCII code, right? It's a declarative language. It declares that certain things should look one way or the other, that it should be formatted as headings and paragraphs and lists or tables, right? But it didn't have any functional programming, right? It only declared that certain things should look one way or another. So JavaScript was the first attempt at introducing functional programming, right, to the browser, being able to execute some applications or programs or algorithms within the browser. And so what they did is that they introduced a new tag called the script tag, right, that allowed us to embed JavaScript or functions or statements, right, inside of the script tag, right. And the script tag would you know coexist along with other HTML tags such as headings and tables and lists and whatnot, right. But the difference is that the code that you would put inside of this script tag would have the capability of interacting with the browser dynamically, right? So that instead of you having to hard code, writing a heading or paragraph hard coded in the ASCII, you could instead write a program inside of the script tag to do the same. You could programmatically add a heading or a tag or a paragraph or list, so that first perhaps you could instead of hard coding a list of items, right, in a hard coded UL and a hard coded set of LIs, instead you could have an array, right? You could have an array of objects, right, that you could iterate over, right, and then do the same thing. You could generate the line items dynamically as opposed to hard coded. Okay, but then you might say, well, if you would have this exactly the same array, right? Well, what's the point? Might as well just write it uh, statically, right? But then, in addition, it gave us the possibility of interacting with the user, right? So that if the user clicked on certain things, we would be able to, execute certain functions, right? So we'd be able to react, right, interactively with the user, as they clicked and drag and move the mouse and press the keyboard or whatnot, right? We would be able to capture those events, right, and convert them into modifications of the data structures, and then the updating of the user interface dynamically, right? And the basic mechanism is of drawing something on the screen on a on a browser is to manipulate the DOM, right? The document object model. The document object model, if you remember, right, it's a data structure, right, that the browser uses to represent the screen, whatever's drawn on the screen. So what's this? The JavaScript language gave us is an API, right? It gave us a set of functions that would allow us to manipulate the DOM and therefore be able to draw things on the screen however we wanted. Okay. So here's an example of the most trivial JavaScript applications, right? It's just a simple alert, right? And so the alert function just pops up a little dialog with whatever text you have in there, right? And this script tag would coexist inside of any portion of an HTML document, right? Now, we're not going to be working with low-level JavaScript, right? I mean, certainly we could, right? Inside of an HTML document, we could put a script tag, right, and start writing JavaScript in there. But that's not the focus of this course, right? We are programming at a little higher level of abstraction, right? We're not writing, plain old JavaScript. Instead, right, we are writing JavaScript, at a much higher level. Actually, we're not even using JavaScript. We're using TypeScript. TypeScript is it's a better version of JavaScript, right? That it's JavaScript with types, right? It's a type safe language, right? So we're writing these functions, right, in TypeScript that and it's not even only just TypeScript, right? It's TypeScript mixed in with XML, right? So it's the extension is TSX, right? Not even just TS, it's TSX, meaning it's a language that is a merge of two languages, right? It merges the the high level JavaScript, also TypeScript, right, with also the HTML. It tries to blur the line between these two worlds, right? That allows us to embed, the HTML inside of JavaScript, right? So that with the intent that whatever HTML gets generated from those algorithms or from those functions would be then used to manipulate or update or somehow affect the DOM, right? So that the DOM is then draws whatever we want on the screen, right? So yeah, so components up here, right? They generate DOM pieces, snippets of HTML that have been calculated through an algorithm, and then React, right, converts this high level TypeScript, TSX, right, mixture of JavaScript and HTML. It converts it into a lower level version of JavaScript, right? Because browsers, they don't all understand TSX just yet, right? They all understand just plain old JavaScript, right? But they don't understand TSX. They don't understand this high level, right, language of a mixture of TypeScript and XML. Instead, it gets transpiled, something that is almost like a compilation, but compilation typically we think of when you're compiling down to a binary. We're not, right? We're just converting from a higher level language to a lower level language, which is still JavaScript, still human readable, right? It's not binary or anything like that, which that can then be understood by any browser, right? Well, by most browsers anyway. And then the HTML, the single page, the index.html single page, reads these JavaScript files, runs them inside of the browser, and it manipulates the DOM, right, drawing anything we want on the screen dynamically. Make sense? Anyway, so this is where we are. We're at a high level. But it's useful to to take a look at what's really happening behind the scenes, right? So let's spend some time, right, at least for historical purposes, right, on what has been or what's happening downstream at a low level, right? All this high level TypeScript gets converted into this very low level JavaScript, and it's unlikely that you'll find yourself writing plain old JavaScript, but nevertheless, here's a quick overview of how you would use it, right? But we won't ask you to do this on any exam, right, or assignment or project, but nevertheless, it's useful for historical purposes. So here are some of the basic commands, right, that JavaScript gives us to generate content for the user, right? It could be an alert function, right, to pop up a simple dialog with some text. We can write out to the console. This is more for developers, right? We write out to the console, and you can look at it through the inspector. Or if you want to write something to the screen, right, to the document, to what's rendered on the screen of the browser, you could use the document API, right? The document is an object. It's a global instance of an object, a singleton, right? That has a reference to the DOM, right? It allows you to interact with the DOM. So the document object allows you, provides functions that allow you to write to the DOM or read from the DOM, manipulate the DOM, right? Again, it's a hierarchical data structure. It's an inverted tree, n-ary tree, right? And the document allows you to traverse this tree, right? Looking for elements in the tree by their ID, allows you to snip, move nodes from one part of the tree to another part of the tree, and whatever you manipulate this tree, right? You're manipulating the user interface, right? Whatever it's drawn on the screen. The simplest of commands is the write command. So document.write allows you to add, right, to this tree, right? Add content to the tree, add a node, a text node to the tree, right? So document.write in hello world, where it creates a text node, right, and it appends it to the DOM, right? And then whatever you add to the DOM, you're adding it to the screen, right? So that's the simplest way of just drawing something on the screen. So not only can you write to the screen, but you can also read from the DOM, right? You can traverse this document, this data structure by using functions such as get elements by ID. Right? Remember, you can give unique identifiers to elements by using the ID attribute, ID and then some unique identifier, right? So document.get element by ID will do a traversal of the data structure, right, of this tree, looking for an element whose ID is whatever you give it. Okay. Once it finds it, if it finds it, it gives you a reference back to the node, right, in the tree where that is found, right? So it does a a breadth first traversal of the tree, looking for this element. Probably have some indexing, right, so that the IDs are well indexed and have direct references to the nodes, right, as opposed to doing a full-on traversal of the tree. So once you have a reference to the node, you can then manipulate it. You can delete it, right? You can copy it. Or you can manipulate its content, right? So for instance, you can manipulate, the internal HTML, right? And you can replace it by writing to the inner HTML property, right? So you say document dot get element by ID. Now you have a reference, and you can say dot inner HTML, right? And then you can put either plain text or something formatted. You can do some paragraphs, some headings, right? You can put it in there, and it'll render. Your new update will render right on the screen. So here's an example of a heading, right? You have with an ID of hello, has a hello world, right? And so if we write in the script, you could grab a reference to this heading, right, by its ID, by using the get element by ID hello, right? That's the ID. And once you have a reference to it, you can store it in a local variable, right? Notice that we're using the keyword let, right? The name of the variable, and then we are assigning a reference to that node that we just found. Once you have a reference to it, you can start manipulating various properties of the object, right, of the node, including what it looks like, right? It's the style, right? The style is being able to manipulate all sorts of CSS properties, right? Last lecture we explored all these CSS properties that they can manipulate, right? The foreground color, background color, right? The font, and so on. So they're accessible through this API, right? The element dot style, and then style contains all the CSS properties that you can manipulate. Now, if you remember, we were making the distinction of CSS properties that you can manipulate either through the style attribute, right, where you would provide a JSON object, right, and we pointed out, right, those properties in those JSON objects were camel cased. Remember that, right? And this is to contrast with CSS properties that if you're using just plain old CSS, they're not camel cased, right? They use dashes, for separating compound words, right? And the reason, so to point out that that fact of the difference of the names of the properties, one using camel case and the other one using dashes. Well, the reason we have this second alternative of camel case names for the properties is because of this, right? See the actual property names, right? When you access through the API, right, the property names are well-formed camel-cased variable names. See that? So font size, for instance, is capital S, right? It's not font dash size, right? It would make no sense to have that as the name of a property of an object, right? So that's where it comes from, that the properties are camel case. It's because they're a direct access through the API of manipulating the CSS style attributes, right, through the document API. There it is. See that? That's why it's the naming difference. Other things that you can manipulate is the display property, right? If you remember last lecture, we talked about modifying the display property so that we can hide or show content, at various screen sizes and whatnot. Well, you can also manipulate it programmatically, right? You can say style.display, right, and then assigning it either none so that it would hide, or block so that if it's a block element, it would display using the block rendering algorithm, right? It would take up the entire width of the screen, right? Well, yeah. So we learned how to use it using CSS. right? And here now we can also just use it, do it programmatically, perhaps as a result of some complex algorithm, some complex criteria, computational criteria. Also, JavaScript introduces several new data structures, as you would expect in any modern programming language. It has the all the common data types, right? So it has date, obviously, numbers, strings, and Boolean, and so on, right? So all the data structure, primitive data types that you would expect in any modern language. So here's the date class that you can instantiate an instance of a date, and once you have that, right, you can access its API of retrieving the month, the day, the year, the week, right? The full blown formatted date allows you to parse dates, generate it and format it in which way you want, right? So here's an example of once you have a reference to the date today, so new today gives you a reference to the current date. This is using the browser's access to the operating system, right, to determine what the current date is, so whatever the local date of where the browser is running on the local machine, right? And so once you have the date, you can get the month, you can get the full year, right, and we can write it out to the screen. Okay. Also, you have certainly you can work with objects and arrays, right? And arrays are easy to declare, right? You can just use the square notation and then use comma separated values in there. One thing that it's good or bad, it depends how you see it. JavaScript allows you to mix and match data types, right? So here's an example of an array that has numbers, but certainly you can declare arrays that have strings, right? Or Boolean or whatnot, or a mix and match, right? As far as JavaScript is concerned, right? It makes, it doesn't care about the data typing. That's where TypeScript comes in, right? TypeScript, corrects this this issue, right? If you're coming from a C# or Java or any of these strongly typed languages, right? When you see a non-typed language, you might balk at it and says, "Wait, what?" They're very error prone, right? And that was one of the weakest points of JavaScript for years, for decades, right? That it was very very easy to write buggy code, right? Because there was no type safety, right? It was a if there was a bug, right, you would only determine that at runtime. You would have to run the application, you would have to crash, right, for you to and you determine that there was a bug, right, and then you would have to debug it. So with type safety, certainly that goes away with TypeScript, right? You can identify those bugs much earlier, right? While you're coding, right, the IDE can tell you that you're assigning wrong data types and whatnot. But plain JavaScript is totally fine, right? You can have an array of mix and matches of data types. There's no validation whatsoever. So yeah, it is what it is. So yeah, so here's an example of declaring a simple array of integers, right, whole numbers, and then just writing out that array to the screen. And here's an example of iterating an array, right? It's what you would expect, right? It's a simple for loop where you declare the initializer of the index, right? And you iterate over the length of the data structure, right? And you can declare all sorts of variables to add up, accumulate the values, and then calculate the average. So here's an example of a simple average of quizzes, right? So again, we're getting a little more sophisticated here. So not only can we write out simple text and some simple formatting, but you can write entire tables and lists and whatnot. So here's an example of writing out to the screen a full-blown list, an unordered list. You write the UL, right, with its own pointy brackets, right, and then iterating over the array, and then you're writing the line items, right, so that we can write out all the scores of all the quizzes. And here's a more involved example of using tables instead, right? You are calculating a string for the HTML, that this starts off with table, and as you iterate for the scores through the scores in the array, right, you're creating a table row for each one of the quizzes, right, where you can have multiple columns The first column being the scores, right, and then several scores in there, and notice that here we are accumulating, right, the strings of the formatted HTML, and then once we have the entire table, right, concatenated, and then we write out the table out to document.write. Yes. Now, this is very, very error prone, right? Whenever you're using one language to generate another language, right, that's very, very error prone, right? Because notice that we have a whole bunch of string concatenation, right? We have all sorts of these pluses, right? It's very, very easy to get this wrong, right? That you're missing a colon here or a quotation mark over there, right? It's very easy to make a mistake, right? And that's where JSX comes in, right? The marriage of JavaScript and XML, right? You can easily make this much more readable, right, using TSX, where there is no need for concatenation, right? You just embed, right, the HTML instead of JavaScript, and all these concatenations, all these pluses and quotation marks, they all go away, right? And that's the intent of using this higher level version, right, of TSX, so that we don't have to deal with this, with this very low level error prone mechanism, right? Now, obviously, behind the scenes, our very high level implementation of TSX gets compiled, well, not compiled, transpiled down to this, right? This is what actually, right, gets generated in what actually the browser understands, right? The browser understands this. It doesn't understand the high level TSX, right? And that's what React does, right? React does a conversion of the high level functions, right, of these high level components down to low level JavaScript here that any browser can understand. Make sense? Right. So not only can we generate formatted content, not only can we compute content dynamically based on some data structure, right? But we can also interact with the user, right? We can listen for incoming user events, right? Also, anything from typing at the keyboard, moving the mouse, right? Moving the mouse pad, right? So any user input, right, is accessible to the JavaScript language, right, including the camera, including the microphone, right? Any input from the hardware, there'll be some mechanism that allows us to input into the user interface, right? So here's an example, really trivial example of a button, right, that we can click and we can capture that event, right? And we do that by declaring functions, right, that usually refer to them as event handlers, because we are going to generate an event, right, by user interacting with the hardware, right? And we want to declare a function that is going to handle that event. So we're saying, on click on this button, right, invoke this function, say hello, right, and then we alert the hello. And so here's a really simple example, right, of declaring a function instead of a script tag, right, and then we can call that function, right, when by assigning it to an on-click event handler. Okay. Now notice that all these scripts have been are written, embedded inside of the HTML document. Now, typically, these declarations happen at the head of the HTML document. That's a very common place to put all these functions, right? Now, and obviously you would have the the HTML, the formatting tags, accompany, right, the rest of this declaration of these scripts, right? But a much better version of this, right, a much better approach is not to include the code inside of the HTML, embedded inside. Instead, a much better approach is to declare all this JavaScript code outside, right, in separate files, right, that can then be imported by the HTML document, right, using the same script tag, but now use the source, right? The source attribute allows you to point, right, to a JavaScript file that lives in the same file structure, or right, we could use an HTTP request to go out and download, right, a JavaScript file from anywhere from the web, right? And so that's actually how, right, you can write React applications, right, that can reference the library of JavaScript that is hosted by either Facebook or any DNC uh, um, that has this all these libraries being hosted. Now you'll see in some places that even though typically scripts tags are declared in the head, right? That's the proper syntax. It is a very common practice to instead put them at the bottom of the script at the bottom of the body tag, right? At the very very bottom. And the reason for this is that some of these scripts could be very large, right? Especially if you're downloading several libraries. Maybe you're downloading a 3D imaging library and some video library, and these might be pretty heavy libraries that might take you a couple milliseconds to download, right? And perhaps you're downloading quite a few of these, right? Plus your own code, and so that means that all these scripts need to be downloaded. They need to be parsed, right? They are executed immediately. That's one point in the JavaScript, right? That these codes are implemented, instantiated in, and if there's a function to be called, right, it'll call it right away. And so it might take you a while. And this is even before you get to the body tag, right, where you have the main content. That means that if this is a very complex website, it might take you a few milliseconds before any content is drawn on the screen, right? And and we have a very finicky audience, right, that is not willing to wait, a couple of seconds, right, for the content to be downloaded. You might lose a customer, right? They might just navigate away from the website if it's taking a little bit too long to download, right? So a very common practice is to instead put all these scripts at the bottom of the body, right? You put them way at the bottom, right? It's the very last thing that gets downloaded by the browser, right? So it's a very high, expensive library. That's fine, right? In the body, at the very beginning of the body, you pump as much content out to the user, right? Especially, some eye candy or some marketing, right, image or video, at least to capture the attention of the user, of the customer, while right at the bottom of the screen, you have all these libraries are downloading, in the background, right? And then once the library are downloaded, obviously they can take over the page, right? All the dynamic content can start being rendered, right? But at least you've captured the the attention, from the user so that they don't navigate away, right? And that's a very common practice, right? Especially high performance websites, right? They'll pump static content at the user as fast as possible, right? And then in the background, right, they'll start downloading scripts that do all the dynamic stuff, right? So anyway, yeah, so to be able to manipulate the content dynamically, right? We can grab the reference of an element by its ID. So let's take a look at implementing a very simple calculator, right? So imagine we have here a 2 plus 3, and then we have in a span, right? With an ID of results, it's empty at first, right? And that's where we're going to dynamically compute, right, the result of our trivial calculator, right? And this is only to get a flavor of what it used to be, right, to code in JavaScript before React. Yeah, so here we have 2 plus 3. We have the span with an ID of result, right? And then here, later on in the code, we can grab a reference to the result element, right, with the ID, and then we can dynamically, write to the span and write the actual value of the computed value of 2 plus 3, and then it would render as 5, right? Now instead of hard coding the 2 plus 3, these could be input fields, right, where you can write the values of 2 and the values of 3, and then press a button to plus, to add, to subtract, divide, and whatnot. So for us to be able to enter data, right, we need input fields. So input fields, as we saw early on in couple lectures ago, right, we introduced the input field that allows us to type in some value, right? So we have here the value of the variable a. So we uniquely identify them as a. We give them initial value, and then programmatically we can get a reference to the input field, right? And we can read the value of the input field by saying, input field dot value, and then here we're just alerting it. But this gives you a hint, right? That we can interact. Not only we can write content, but we can also read content from the input field where you might have typed some value, right? So for instance, here's an example: two input fields, A and B, right? That are going to be added, right? And then the ID C that is going to show the display, right? And so, but because it gives you input fields, you can write any values there, right? And if you click on this button that says add A and B, it's going to invoke add A plus B, right? That this function reads the content of A, reads the content of B, right? And then calculates the arithmetic value and then updates the inner HTML. Notice that once we get the value of both A and B, right? By default, the content are strings, right? So A and B are strings. So careful, right? Because the addition, then it would be interpreted as a string concatenation, right? So instead, what we do here is that we're parsing them as integers, make sure that they are of the correct data type, and then so that this plus is correctly interpreted as arithmetic addition, okay? All right, so yeah, so those are simple primitive data types. You can also combine multiple data types, right, into a single object, right, with several properties. So here's an example of declaring a house object with 3 properties: room, bath, and square feet. They all have they're not all numeric data types, right? And it's declared by using the curly brackets, right? So you can create a house equal to curly bracket, right? And then you can list the properties in there and use colon to give them values, initial values for each one of the properties, and then comma to separate each one of the properties, right? So this notation is called JSON, right? Which stands for JavaScript Object Notation, and it has become by far, right, the most common format for exchanging data, right? And the reason is because many applications have been moving, right? They've been implementing versions of their desktop application. They've been implementing web versions of these same applications, right? And because they're running inside of a browser, they often need to talk back to some server, right? To interface with some data with some database, right? Or some file system and whatnot, some operating system operations. And the way you interact, right, is through exchange of some data types that are friendly to the JavaScript language, right, that is running on the browser, right? So that's why it has become so very, very common. Even if you're not writing a web application, right, JSON, right, has become a very, very popular format to store data and exchange data. Okay. So here's an example of using the object notation, right, to populate a simple HTML list here that has line items for each one of the properties: rooms, baths, and square feet, right? And here we have a little example of retrieving each one of the items in the DOM, right, and then changing its inner HTML, to set them to the value of the object dot rooms, the house dot rooms, house dot baths, and whatnot, right? All right, so let's take a look at some exercises, right? And these are taken from the assignment 3, I believe, right? And so it's going to give us a chance to practice some of these skills. All right, so let's talk about JavaScript variables, right? So like any language, right? We can declare very simple data structures, such as the primitive data types, obviously, strings, numbers, booleans, things like that. But then also compound data types such as objects and arrays. So let's learn a little bit about that and how is that we can work with them. Okay. So first, right, we have to learn a little bit about the history of JavaScript, right? I believe in 2015, there was a major update to the language, right? And so the language has had several versions, and up to 2015 it was version 5, right? Version 5, and the actual name of the language, it's a ECMAScript. That's the official name of the language, right? And hence the acronym ES for ECMAScript. And so in 2015 there was a major update to the language, to version 6. Okay, that brought in tons and tons of features that developers were craving, were clamoring, asking, begging the the folks that were designing the language, right, to give them these features, because it was falling behind many other more modern languages, right? And so one of the features was that we abandoned the use of the var keyword, right? The var keyword had like the name suggests, right, it was for declaring variables, and it's still supported for backwards compatibility. But we're going to avoid using this legacy keyword. Instead, we're going to use the newer keywords let and const. Right? Let allows you to declare variables, right, that can change over time, whereas const, right, is for declaring constants, meaning you can only set them at the beginning when they're declared, and then you can't change them. Right? So let and const, no var. Okay. And other things, well, obviously, you have the Java script notation that this has been around for quite a while, right? Where you can just pointing out that you can arbitrarily you can create arbitrarily complex data structures, right, of objects that contain other objects that contain primitive data types, arrays of objects of arrays, right? So it could be you know uh, you know, it can be arbitrarily complex, right? And you can use the very common notation of the dot notation and the square brackets notation to navigate through the data structure, right? Which is very common in all languages. Now, a couple of things that changed between the ECMAScript 5 and ECMAScript 6, right? So a few things that changed. First, right, we abandoned the var, right? And instead we introduce the variable let. Okay, and this introduced the fact that you can scope variables, right? Now variables could be scoped within the uh, code block, right? Like, for instance, you could declare the variable I now, right? Let I, that only existed within the curly brackets of this for loop, right? This was not a thing, right? Before ES6, the new version 6. Right? It used to be that they had to be declared at a higher scope, right? And you could not declare them inside. So that was definitely a great improvement. Same thing here. You could declare X, inside of the for loop, and once you fell off the curly bracket, then the variable X didn't exist anymore. I mean, these are basic features, right? That all languages had already by this time. All right, so let's create a couple of exercises, right? Let's create a couple of uh, some components, right, that are going to allow us to practice some of these features, right? So I'm going to create, instead of lab 3, a component where we can practice variables and constants. So let's do that. So instead of lab 3, right, we can create a new TSX, all right, and then in here we'll have a function. Let's copy that. So this is declaring one variable. It's a no-no. You should not use variables, but here I'm just doing it for posterity. Then we're declaring a variable and a constant that can only be set in a declaration time, right? And then so yeah, this is things that you should already be familiar with. The only thing that I want to point out here, right, is this new syntax. You look at this curly bracket. So this curly bracket, right, it says that what's inside is an expression, right? It's not the literal function scoped or block scoped or constant one, right? These are these are commands, right, to the React infrastructure, right, that this should be replaced, right, when this gets transpiled, it should be replaced with the calculated value of the constant or the variable or the var or whatever, right? So this will be, function scope equal 2, block scope equal 5, right? And constant, 2 minus 5 minus 3, okay? Right? So yeah, again, the intention of TSX, right, is to make it very, very easy to go back and forth between JavaScript, into HTML, and then with the curly brackets, go back into JavaScript, right? And then when you close the curly brackets, you're back in HTML, then back in JavaScript, then back in HTML, seamlessly, very easily going back and forth without, right, the terrible alternative of having to use concatenation, right, which is very, very error prone. Okay. Anyway, yeah. So let's load that new component into the lab3 component. So this is the variable and constants. So let's see. So variables, and constants. There we are. Let's save that. And now if we go here, there it is. See, welcome. Variables and constants. Let me put that to the side here so we can follow along. There we go. And let me open up my IDE so that we can see what we're doing. There we are. So yeah, we were able to write to the screen just simple variables. All right, excellent. All right, so let's do something a little more interesting. So here's just to, we're just introducing the fact that there are various data types, right? So obviously there are numbers, right? There are strings, there are booleans, right? And there's also type of. So type of is a operator, right, that allows you to, calculate what is the type of a particular variable, right? Whether it evaluates to a string. So for instance, is number, right? Type of a number variable, right? It'll give you the string representation, right? Whether it's a number or string and whatnot. So yeah. So let's let me illustrate. So let me create variable types. And this is a trivial example, but it is going to give us a chance to discuss a fairly important aspect, right? Let me load it up into our lab3. So I'm going to, so this is variables and what was it called? Variable types. There we go. Okay. Okay, there we go. So we got 2, 5, and oh, there we go. 1, blah, blah, blah. The number, right? Floating point number. This one because it's 234.345. The string, variable strings, right, with a curly bracket. Okay, this is what I want to point out. Notice here that it says Boolean variable plus string. See that? Right? And what's the value? Well, it's just that it's the value true. See that? The value true. So you would expect, just like the numbers and the strings, rendered as the numbers in the string, you would expect that true would render as true with the string true, but that's not true. Notice that if I remove the quotations and I save that, notice that it does not render. See that? The true doesn't render, or false, or whatever it is, it will not render. Right? Instead, what we're doing here is that we are concatenating it with a string so that we're basically casting it into its string representation before it gets rendered on the screen. See that? And that converts it into the string true, T-R-U-E. Right? Now, why is that relevant? Well, that's actually a feature. You might say, well, is it, why are all the other data types rendered fine except the Boolean? And that will become apparent in a minute as we go into a couple other examples. But the intention is that since this is going to allow us to combine Boolean expressions, combine them with formatted content, right, or components, so that if the Boolean expression renders as true, it will render, right, the other component. But if it renders as false, it will not render the other component, right? So it can be used to toggle, right, the rendering of one component or not, right? Whether the Boolean is true or not, right? And what we don't want, that if it gets rendered, we don't want to have the keywords, right? The text TRUE kind of like concatenating with the rest of the content, right? It would be very annoying. Rather, we have to somehow strip that out. So the React does that for us, right? If something evaluates to a Boolean value by default, right, it's just not rendered. Okay, you would have to coerce it into a string, right, for it to render. Okay, and that's what we're doing here. Anyway, that's a pretty cool feature that we'll see in a minute when we look at Boolean operators in a minute. Okay. Oh, there we go. Boolean operators. All right, so let's create a Boolean variables here, and let's take a look at that. So we have Boolean variables, and we need a function, the export default function Boolean variables, variables. My AI is acting up. No, it's a little bit too aggressive. All right, so return, there we go. Okay. So yeah, so let me copy this. Let's see, copy that. And let's replace that with that. There we go. Okay, so some of the exercises, walk you exactly what you need to type. Some other exercises don't, right? Some of the other exercises kind of give you a hint on what you need to do, but it doesn't actually spell it out exactly, right? So be careful, right? As you go through the lab exercises, they get progressively more challenging, right? They do a little less hand holding as you go through the book, through the exercises, right? And that's just to give you a little bit of leeway, right? And of you trying to figure it out, on your own. All right. Anyway, so here we're declaring a couple of numbers, right? 1, 2, 3, 2, 3, 4. A couple of Boolean values, true, false, and introducing the operators, the and operators, the or operators, the not operators, right? Again, they behave just like you would expect in any other language. But also you have a couple of comparators, right? To compare things to be equal, not equal, greater than, less than, and whatnot. Yes. Now, and all of this is very, very similar to what you would expect in any other language. Now, I do want to point out something peculiar about JavaScript is that notice that we are using the triple equal operator, right? Not the equal operator. I mean, that's what you would typically use in Java or C#, right? You would use the the equal operator to determine whether compare two values whether they're equal or not. Well, in either a feature or a flaw in the JavaScript language is that equal it evaluates to something that is not necessarily true or not necessarily false, right? It's actually evaluates to something that is truthy, right? Or it's enough of a true that you might consider it good enough, right? Or falsy, right? Not necessarily false, but and let me explain. What it does is that when it compares a number, when it compares variables or literal values, right? What it'll do is that it'll try to cast one into the other, right? So if you're comparing things that are of the same data type, then equal is fine, right? If you're comparing numbers to numbers or characters to characters, right? Then equal is just fine, right? The problem is that when you start comparing things of different data types, right? And this flaw comes from the fact that the language is not type safe, right? By default. And so what it would try to do when you're using the equal operator and you're comparing things that are not of the same type, it'll try to cast one of the sides to the other, right? So for instance, if you have character 1, right, equal the number 1, what it'll try to do is cast one into the other, right? It'll try to parse, for instance, the character 1, right, into the number 1, and then do the comparison. And in that case, then character 1 is equal 1, right? So it's not which it might be fine if you're doing some really simple stuff, right? Or you are being very careful about the type safety, right? But you could very easily run into these uh, unintended comparisons, right? And inadvertently compare things that are of the wrong type, and something is evaluating to true when it should be false. Well, actually, it might be that you shouldn't even be comparing them, right? So for that, we are not going to use the equal equal. It's a bad practice to use equal equal in JavaScript. Instead, we're going to use the triple equal, right? So the triple equal is what behaves the way you would expect, right? What it does is that it first checks, makes sure that the both sides of the correct data types of the same data type. If they're not of the same data type, it doesn't even compare them, right? It immediately evaluates to false, right? So if they're not of this, if you're trying to compare strings to integers or booleans or whatever, right, it'll just fail it and evaluate to false, right? Only if they are of the same data type, then it will actually compare them, right, to see if they're the same or not, right? So from now on, please do never use equal equal. It's always triple equal. Same thing with the not equal, right? The regular operator is exclamation equal. Instead, don't use that. It's use instead exclamation equal equal, right? That again evaluates make sure they're the same data types, and then it uses a proper comparison. Make sense? Okay. Then obviously you have all the other comparators, right? Greater than, less than, greater than, equal to, and so on and so forth, right? So anyway, so these are a couple of examples of those, and we can load them up into our lab 3, Boolean variables. There we go. And let's import them. And then we can render them. There we go. So true, false, and whatnot. Okay, excellent. Let's see. Let's take a look at the conditionals. So conditionals, again, like any programming language, you have, the if statements, the if else statements, and whatnot, right? Plus, you have, the tertiary operator, you have the ands operators and whatnot, right? So let's discuss this a bit. So for instance, here we have in the if else. And let's create a component here where we can play around with this. There we go. So we'll need a function. So export false function. Oops. What is it? If else. There we go. There we go, like that. Okay, and then let's copy this. So here we're declaring a couple of variables, right? And then we have a div here that's going to render a few things programmatically. All right, let's take a look at this, how it renders. Let's load this into lab 3. So this is if else. There we go. That. And it renders as this. Okay, true 1, if else, true 1, and false 1. All right, so let's take a look at the example. All right, so what are we doing here? So notice that we're declaring a couple of Boolean variables, right? True 1 is true and false 1 is false. And notice here this expression. See that? Again, we have to, whenever you see this curly brackets, right, embedded inside of a return, right, embedded inside of a whole bunch of HTML, you have to think of it as an expression, meaning your JavaScript is going to evaluate the expression in there, and whatever the result of that expression is what's going to be rendered, right? And so notice that what we have here is that we have the Boolean function variable true 1, which is true, right? And notice the and, see that? So we're using the and operator, but instead of anding one Boolean expression with another Boolean expression, which you would normally do, here we're anding, right, a Boolean expression with a formatted HTML code snippet. See that? And this is what I meant by using a Boolean expression to be able to toggle, showing or not showing a piece of content, right? Since we have true 1 here, right, and it's true, then this paragraph evaluates this true 1 right here, right? Since true 1 is true, right, this paragraph renders. There it is, right? So since true one is true, then this paragraph renders. If true one were false, like that, save, notice that it doesn't render, right? So again, the reason why we don't render the keywords, the Boolean keywords, FALSE or TRUE, right, is because we would like to be able to combine it, in Boolean expression with code snippets like this, right? And then they can drive, right, the logic of whether I'm going to show an entire piece of content or not, right? I can now programmatically determine whether I want to display this piece of content or not. Like maybe you're clicking on delete or hide, or maybe you're clicking on collapse, or and you're toggling show and hide, and whatnot, right? So yeah, and then this becomes true, and then it shows again, right? Okay. The other way to either render one thing or another is to use the ternary operator, right? The ternary operator, typically, right, on the left side of the question mark, you have a Boolean expression, something that evaluates to true or false, right? And then on the right-hand side, you have two possible outcomes depending on whether the expression is true or false, right? If it's true, then it evaluates to the second argument. If it's false, then it evaluates to the third argument, right? That's what it's called, ternary, right? Ternary operator. And so now, because false here is false, right? And then you say not false, then this whole thing evaluates to true. That means that it renders this first part right there. Right there it is, false one, right? Or not false one. Now, if this were true, right? Notice that it renders false one as opposed to not false one. See that? Right. So you could have expressions that have a very complex algorithm that evaluates to true or false. Maybe you're logged in or not logged in, right? And then you show either a greeting saying, "Oh, welcome, Alice," right? Or you would say, "No, sorry, I don't know who you are. Please log in," right? And based on this on this Boolean operator, right? All right, let's talk about functions. Yeah, so with ES5, right, the prior to 2015, you only had one version of functions, right? You have the what we call now legacy functions, right? And you declare them just like you would in many other languages, right? You use a keyword function, the name of the function, and then you have the parameter list, right, curly bracket, and then you have the body of the function, right? So just like many other programming language. So in ES6, right, in the ECMAScript 6, they introduced what is called today the arrow functions, right? It's a different syntax, and from these two examples, they don't look very different, right? But let's take a closer look. We have here, instead of there's no function keyword. Instead, we are declaring a constant, and then we are assigning it. See that? On the right-hand side, the value, there's a literal value, just like you can assign a constant, you say equal, and then a little, integer or a little string or a little Boolean, whatnot, right? You can also assign a literal function like this, right? So here's a function on the right-hand side. So the right-hand side evaluates to something of type function, right? Which notice that it has the same A, B, parameter list like we had in the legacy function. Then instead of the keyword function, the reason we know this is a function is that we have the arrow operator here, right? Equal, greater than, right? So we know that this is a function, but basically it's saying that you give me these values and I will evaluate to whatever's on the right hand side, and then what's on the right hand side is just a curly bracket that is the body of the function. Yes. All right. Just looking at these two, really, there doesn't seem to be any improvement. But let's take a closer look. Right? Okay, so a new feature that the new syntax brings is what it's called the implied return syntax. Implied return syntax. Now, whereas in the older syntax, you always had to, well, optionally, right? You had to have a return, right, where the function evaluates something. You wanted to return some value. You would have to use a keyword return, right, and then the value that you want to return. Well, the return keyword is optional in the arrow function, right? When you use an arrow function, you can absolutely use the return like you would normally do in the legacy function, but you don't have to, right? You could instead just use the expression as the return, right? A plus B, and just drop the return. But you have to be careful. This only works if the return is the only expression in the body of the function. This is the only case in which where this syntax can be used. Okay? For instance, in this case, we have a return A plus B. That is the only statement, right, in the body of that function. Then we can very easily just drop the curly brackets. Very important. You have to drop the curly brackets, right? And you drop the return. And then you just become with A plus B like that. Make sense? Right? Now, okay, so this is a nice feature, right? Especially because it's very common in JavaScript where you embed functions instead of other functions, right? And so all this nesting, right, it makes it hard to read the code, right? But if you start dropping off some of this optional syntax, right, like the curly brackets and the return and whatnot, the code becomes very, very much easier to read, right? So that's one of the reasons, right? That this is a great feature, especially how functions are used inside as callback functions, right? As event handlers and whatnot. That is a very common use case for functions in JavaScript, right? This makes it so much easier to read. Another syntax difference is that the parentheses, right, in the parameter list, okay, are optional. Okay, so for instance, here we have square ES5 takes as argument B, right, and then it returns B times B, right. Well, the equivalent, right, in using ES6 is that B, right, the parameter list B, right. Notice that we have no parentheses around it, right? And because the return is just a single return, it just writes the body is just B times B without the return, without the curly bracket. So notice how much more terse, right? How much more compact, right? This syntax is. It's so much easier to read than the 3 lines of code, right? So the 3 lines of code becomes just a single line. You're trivial to read. Okay. Now, this only works if the parameter list only has one argument, right? Here, in this case, it's indeed, right? We have just the single variable b, right? So we can drop the parentheses. Now, there is a debate, right, in the community on whether this is a good practice or not, right? That actually the extra parentheses actually makes it easier to read, easier on the eyes, right? It highlights where the parameter list is. Without the parentheses, it might make it a little bit harder to read, right? I'm on the fence. I like it without the parentheses. I have no problems with that. But most IDEs will force you to put the parentheses in there, so that if it'll highlight it as a not a syntax error, but it'll highlight it as a bad practice, right? And it will put in the parentheses in there for you. Okay. Another thing that was tremendous, was huge in ES6 is the re-implementation or reinterpretation of the keyword this, right? Now, in every other language, the keyword this, it's clear what it means, right? It's a reference to the current instance of whatever object instance that you're in. If you say this, right, you're obviously pointing to the current instance, and then it allows you to access the whatever property belongs to that current instance that you're in. Well, not in JavaScript, right? In JavaScript, instead, the keyword this just moves around, right? It has different values, depending on which function that you're in, right? Yes, it might be true for the first function, right, when you're instantiating the first class, right, in the constructor. But then as you navigate or change to other functions, you call other functions, the keyword this, right, is different. It points to the current function that you're in, which makes no sense, right? And people hated it, right? And this is still the case, right? This is still the case if you use the old function syntax. That's still the case, okay? But in the new version, right? If you use the new the new arrow function, right? The keyword this actually behaves the way you would expect, right? It is pointing to the correct instance of the correct object instance that you're in, right? Which is a huge welcome, right? That it finally behaves like in every other language. Okay. All right. A couple other things, a couple of minor things. Now you have default parameters, right? Where that if a function takes 3 arguments, you can initialize a few of them in the parameter list, so that you can optionally not provide those values when you call the function, right? So for instance here, f takes 3 arguments, but y and z have initialized values 7 and 42. So you only are required to provide the first argument for x. You're not required to provide the values for y and z. If you do, then certainly it'll use the values that you pass in. But if you don't, that's okay. It always falls back to the default parameters. Okay. All right. So let's take a look at a couple of exercises that will give us a chance to practice some of these skills and even introduce a few more. Okay. All right. So let's take a look at playing around with the legacy function, right? So that we can contrast them with the arrow function, right? So let's see. So let's create the legacy function, and we still use the legacy functions. I mean, you've seen me use the functions keyword quite a bit, right? And I like the old syntax, especially if it's just a component or a screen. But if I'm going to actually write an algorithm, right, that computes something, then I'll use the new arrow function. Okay. It's just a preference. It's a stylistic preference. As long as you don't need the this keyword to behave the correct way, right? The old legacy function syntax is just fine, right? Now, if you do need this keyword to behave the way it behaves in every other language, then yes, use the new and improved arrow function syntax. Okay. So let's declare here the function. Here's our legacy function component, just to play around with this. And what it does is that it just it declares 2 constants. It calls the add function here, which is using the old syntax, right? The keyword function, the name, and then the declaration of each one of the parameters, right? It just returns the arithmetic addition, right? And we just add it up and display the values, right? So trivial. Okay. Let's bring that into the lab 3. Legacy function. So legacy function, there we go. And there it is, right? So we are calculating just 2 plus 4, that's 6, right? And notice that we are assigning it to a intermediate constant, but we're also notice that we're illustrating that you can call the function from within the expression, right? So this expression doesn't have to be just a constant or a variable. It can also be you invoking a function that evaluates to something that I can render, right? So it's what you would expect. Okay, I'm only pointing out that when you use functions and you're calling the functions, TypeScript will force you to to declare the data types of the function parameters, right? Notice that nowhere have we, whenever we're declaring any constants or variables or anything like that, nowhere have we been declaring the data type. Yeah, because all those data types, they were implied, right? The compiler can tell what are the data types, right? Integers and booleans and whatnot. Here in a function, we don't know, right? We can't deduce what you're passing, right? So we want to make sure, right, that the compiler can catch errors, right? If you start, passing the wrong data types, right? So that's why it forces you to declare the data types for functions. Okay. Anyway, so it works the way you expect. All right. So let's take a look at using the arrow function instead, right? The new and improved syntax. Okay. So let's declare the arrow function. And let's paste that in there, and let's take a look at that. And let's import this into our lab 3. So this is the arrow function. So let's arrow function. There we go. And it implements, 3 minus 1 is 2, right? So what you would expect. But let's take a look at the implementation. Notice that the implementation is that instead of using the function keyword, right, it's just a declaration of a constant equal to the literal function declared on the right-hand side. Same thing, we need to declare the data types of the parameters, right? And we are evaluating to return a minus b, right? Notice that the invocation syntax is just the same, right? We call the function just like you would call any function, passing the parameters 3, 1, right? We're logging in and we're displaying at the bottom, right, the values, and we're invoking it again. So using the functions in either syntax, it's the same, right? It's a you can't tell whether one is implemented one way or another. Now, but because we're using the arrow function, though, right? Notice that the only line here, the only statement is this return. So we can use some of our new features, right? We could drop the curly brackets and the return. They're optional, right? Because it is implied. We can use the implied syntax. So we can drop this, we can drop the return, and just do that. Save, and it behaves exactly the same way. See that? Right? It behaves the same way. And notice that this is just somewhat easier to read, right? There's, perhaps it might be easier to read, maybe to put parentheses around this. But my IDE removes it. It says now it's clear enough that it evaluates to a minus b. See that? So that's pretty cool, right? We can we can make it much more terse, much more compact, right? And that was one of the main decision driving criteria of this new JavaScript syntax, right? And so so here's an example of using the implied return, implementing the multiplication. And see that we have the multiply, a times b, right? And then we're calling it multiply 4, 5, so 4 times 5, right? And notice that we drop the curly brackets and the return. Okay, all right, excellent. All right, so let's talk about a string interpolation. So string interpolation, right? It introduces a new syntax of how to work with strings, right? One of the complexities of working with strings is that they could be expensive, right? When you start doing lots and lots of concatenation, right? It has to reinstantiate, right, an entire new memory space, right? It has to copy all the old characters, right, and then concatenate and whatnot. So it's very expensive. It's also, right, all these pluses where you have to concatenate one string with another, and then the variable, and then plus equal and all that. It's very error prone, right? Especially if you're working with very long strings. Right? So what ES6 did is that it introduced a new type of string. Right? In the old strings, which are still they're still used, right? You use two types of quotations, either single quotations or double quotations, and they're interchangeable. As long as you're consistent, right, you can use either one or the other. And they're actually, you can embed one instead of the other. Like you can put single quotes instead of double quotes, or double quotes instead of single quotes, right? But as long as you're consistent, right, you can use them interchangeably. Well, what ES6 does is that it introduces a brand new syntax for strings, right? Where instead of using the single quotes or double quotes, we use the backticks, right? And there it is. Here's an example of the backtick right here. See that? And what it allows you to do, right, is that now you can work with very, very long, arbitrarily long strings, right? You can open up a backtick, right, and then put all sorts of little strings, mix them in with variables, right, and then other variables, then more strings, then more variables, then more string. You can embed entire expressions, right? You can embed loops, right? Maps, filters, all sorts of algorithms inside of the strings, right? And then you close the backtick, right? And then what it does is that it calculates the final result of the string, right? By evaluating all those expressions, right? And then coming out with a single result, right? Without you having to do pluses and concatenations, and which are very, very error prone, right? So here's an example, right, of declaring two objects: the customer object named Alice, and then the card object with an amount, product, and unit price, right, with different data types. And then here's a string, right? The string, notice that there's a backtick right here, opening it up, opening up the new. Now these are called template strings, right? Where you provide some combination of literal strings concatenated with some dynamic uh, expressions, right, that are going to be concatenated with the end result of that template, right? So yeah, you open up the template with the backtick. Hello is a hard-coded static literal string, HELLO, and then followed by an expression. And the way you evaluate the expression is that you open up with a $ curly bracket, and then now you can evaluate functions, objects, constants, whatnot, right? So here we're evaluating the customer.name. So basically we're concatenating the name of the customer. Then hello, blah blah blah, want to buy card amount, right? So that's 7. So we 7 bar for a total of, and notice here we are doing an expression where we are, we're multiplying the amount times the unit price, right, to evaluate, that multiplication, and then we concatenate bucks. See that? So we evaluate this template string, and then we output the result. And notice that it can also span across multiple lines, right? Typically, regular strings, you can't span across multiple lines. It has to be one line, then plus the new line, plus the new line. All that goes away, right? You just have an opening backtick, and then after 40 lines of strings, then you have one closing backtick, right? And then inside, you can have new lines all you want. Okay, so much better to work with these types of strings, right? So here's an example. Yeah, so template littles. Let's see, we are declaring 5. So we're declaring a couple of variables, a couple of constants, right? And where we are, we are contrasting, right? Contrasting, implementing this either the old way where we would do, two, quotes, 2 plus 3 equal close quotes, and then we would concatenate plus 5. See that? But now the way we do that is that we open the backticks, 2 plus 3 equal, and then we embed the expression inside, right? So it's much better, right? And you can also embed, ternary expressions, right? With the question mark and then yes, no, right? And then we display all of them down here. Okay, very, very useful. We're going to use them quite a bit. Okay. All right. So let's talk about arrays. So as I mentioned earlier, right, arrays are one of the compound data structures, right, that allows us to combine multiple values, right, into a single entity. Right. So here we have an example of declaring a few 3 arrays, right, the all, even, and odd. So the all, right, is declaring a single array that has 10 items, 1 through 10, right? And so this is what's called a literal array, right, where we literally use the square brackets, right, operators, right, to declare the items in the array. You can also declare them by calculation, by some argument or some algorithm, right, that calculates the array on the fly. And so here in this case, for instance, even is a subset of the all array, right, where we are iterating over it and we are skipping or filtering out some items, right, which we'll see in a minute. But let me just introduce here the filter function, right? The filter function is a function declared on an array, right, that allows you to filter, compute a smaller version of the same array. It does not manipulate the original array, right? It leaves the original array alone, right? But what it does is that it iterates over the array, right? And what it does is that as it's iterating over each item, right, it calls a function that you declare inside, right? So for instance, here's a function using the new arrow function, okay? And so here we're calling that function repeatedly with the value I, right, which is 1, 2, 3, 4, 5, right? And then for each item, we are returning, right? We are returning the a Boolean expression, the result of this Boolean function here, right, or expression that is either going to evaluate to true or false, right? We are calculating the modules of 2, meaning we're checking to see is it divisible by 2, right? If the module of 2 is equal 0, it means it is indeed divisible by 2, right? And no remainder. Then it returns true. Now, for each item, right, if the expression returns true, then the resulting array is going to have that item, the item that evaluated to true, right? Now, if it evaluates to, so for instance, one modulus 2 is not 0, right? So this returns false. So 1 is not going to be in the resulting array, but 2 modulus 2 is 0, right? So this returns true. So 2 is going to be in the resulting array, and so on, right? So not 1, 2 yes, 3 no, 4 yes, 5 no. So basically even is going to include 2, 4, 6, 8, and 10, all the even items, right? And odd is the opposite, right? Here, if it's we have the opposite expression. If I modulus 2 is not 0, those are the ones that I want, right? Meaning I want 1, 3, 5, 7, and 9, right? So odd includes those. Now notice the syntax here, right? And both of them are using the arrow syntax, the arrow function. Obviously, we don't have the keyword function. That has been substituted by this arrow character, right? These two characters for the arrow. But notice this version here where we are using the implied return here on the right-hand side, and we have dropped the parentheses. Notice how much more compact it is, right, to just declare this nested function inside the filter. How much more the new syntax, the new arrow syntax, how much more useful it is, and makes the whole thing much more easier to read. Imagine having to use a function keyword in here, the parentheses and whatnot. So it would be so much harder to read. Right? So now with a new arrow function, this it's definitely much more readable. Yeah, notice the syntax difference and the equivalence. Yeah, so the arrow function, right, allows us to call filter without having to use the old function syntax, right, that would use the much more verbose version, right? Notice that these functions, even if we use the older legacy function, there's no need to name the function, right? There's no need to give the function any names, right? And the reason is that this function is only being declared inside of this parentheses, and then never again. The function is never used again, right? Only within the context of this these parenthesis call, right, within the filter. So we don't need. I mean, it makes no sense to even give it a name. Right? So we often call these functions either lambda functions, or we call them anonymous functions, right? That they have no name, right? Obviously, an alternative would be to declare this function outside and then pass the function in here as an argument. And that makes sense. If the function is very complex, right, that you have to iterate over a whole bunch of stuff and make a call to the server, blah blah blah. I don't know, access some database, yeah. Then yeah, it makes sense to declare that in a separate function and then pass it here as an argument, right? But in most of the cases, right, these are small functions that you can just embed, right, and just throw them away. They're not meant to be reused at all. Now, a word of caution, right? If you need to debug, right? If you need the extra lines, right? So, for instance, if you in ES5, right? Obviously, you are forced to have the curly bracket, the explicit return, right? And that's fine. Now, in the newer syntax, right? You're not, if the body is simple enough, right? Then you don't have to, right? You don't have to. It's optional, but it introduces a problem. Right? If the function is not working, and you have a bug in there, using the using this syntax, this more terse, compact syntax, there's nowhere for me to put a breakpoint, right, and step through the function. At least this version would put the return in its own line, and I could put a breakpoint there, and I could look at the value of I, right? I can look at the expression, what's wrong with it, why is it not working? Whereas this syntax is not, it doesn't allow me to even put a breakpoint because there's no, there's no statement for me to break, right? So oftentimes folks, what we'll do is that they'll convert this function into this version, right? The older syntax version. So they'll do something like this, right? They'll put the breakpoint, maybe for a console, right? And put a breakpoint here to see the value and whatnot. And once they fix the bug, they'll say, oh, I want to go back to my original, very terse version like that, right? And then what they'll do is they'll forget to, write it correctly again, right? So for instance, what they'll do is that they'll forget to remove the curly brackets, or they'll leave the return, or they won't have the return but leave the curly brackets, something like that, right? And that's and it won't work. It says, why is that not working? Right? It was working when I had the return in the console. Well, why is it? And again, just be careful, right? That you fully remove the return, you fully remove the curly bracket. Obviously, you remove the console, right? Because you only want one expression, right? So just be careful if you're going back and forth, right, and re-implementing in one syntax or another. All right, another very useful function that for manipulating or working with arrays, right, is the map function, okay? So again, the map function works on arrays, right? So you first have to declare an array, or someone else declared it, or just been given to you as an array, right? And what it works similar to the filter, but whereas the filter, right, calculates a new array that is optionally smaller than the original array, right? The map calculates a new array, but of the same size, right? So for instance, if the input array is 1, 2, 3, 4, square is going to be a brand new array. Remember, none of these functions manipulate or touches the old array, right? The old array is untouched. So filter, map, all the others that we'll see in a minute, leave the original array unedited, right? Leave them the way they were, right? What they do is that they create a new array, right? Or a new value, okay? In this case, what it does is that just like filter, it's going to iterate over each item of the array, right? And it's going to call a function, okay? It's going to call a function. Notice that we're using here the arrow function. And basically what it does is that evaluates that function, and whatever that function evaluates to, right? It accumulates all those values, right, and into a new array. So if this were 1, 2, 3, 4, then when it has 1, it evaluates to 1 times 1. You get 1. So there's your 1. Then we get 2. Then it's 2 times 2 is 4. So you get 4. 3 times 3 is 9. 4 times 4 is 16. So square in the end is the squares of the original value of the original array. Okay. Also, we're going to be using map quite a bit, right? It's very useful, and it's very, very popular when implementing and rendering dynamic content, right, in React. Here are a couple more. You have the finder methods, right? So the finder methods, there are two at least. There's find and there's find index. So find, right, again, iterates over the original array, and it's looking for one item, right? So both find and find index, they evaluate to one value, whereas filter, map, and a couple more, right, they evaluate to an array. Find and find index evaluate to a single value. Find returns the value of x, right? The value of x where that makes this predicate true, right? So for instance, if I put 1 here, 1 greater than 3, no. Is 3 greater than 3? No. Is 4 greater than 3? Yes. So it stops. It says, I found the first value. It finds the first value that makes this predicate true. So this evaluates to 4. It says, I found the value 4. There it is, right? Now find index it doesn't return the value, it returns the place where it found it. Where is it? Okay, so if I go through this again, right, I am in position 0. Okay, so it says 1. So 1, which is in position 0, is 1 greater than 3? No. Position 1, right, is 3 in position 1 equal greater than 3? No. How about 4, which is in position 2? So 0, 1, 2. So is 4 greater than 3? Yes. So it evaluates to 2, right? The place, the index where it's found, right? And filter, right? We already looked at that, but here's another example. It returns the subset of array items, right, that make the predicate true. So I want all the items that are bigger than 3, right? So you drop the 1, you drop the 3, you drop the 2, and you end up with just 4 and 5. Okay, 4 and 5. Okay. All right, so let's go through some of the exercises that are in the lab. So here's, for instance, a simple example of working with arrays, right? And there's a couple of arrays here that of different data types. There's the implementation. Let's take a look at it. The implementation. So we have a number array. We have a string array. We have an array of line items, which is pretty cool. But notice the first item is a line item. The second item is a line item as well. Again, that's pretty cool, right? So the syntax of TSX allows you to embed JavaScript inside of HTML, or HTML embedded inside of JavaScript. So here's an array, and the items are, the data types is that they are HTML snippets, right? Then this variable array1, it kind of mixes everything, right? So it puts an integer, it puts another integer, it puts a constant. It embeds an array inside of another array, and then a string array. So all variable array1 has everything, right? And then here we are showing you that we can display each one of these arrays. So here's number array1. There it is, all of them, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So basically what it does is that it concatenates all the values, and boom, it puts them all in as a single string, right? Which is great, right? Because that's not the way the default JavaScript does, right? The default JavaScript actually would show you the square brackets, all the items with the commas and everything. So it would render this, literally this, it would render like that. The way React.js does it is slightly different, right? And they do it for a reason, right? What they do is that they strip out the commas, right? And they strip out the square brackets. And what they do is literally concatenate each one of the items in the array, right? And that's what the result is, okay? And this is what the exercise tries to point out, right? So same thing with the string array, right? There's basically, concatenates both items, and just the result is just a concatenation of the two strings. And finally, this one, right? We're rendering this array, which includes a mix and match of everything, right? And again, what it does is that it concatenates everything out, right? So for instance, we have a function scope, which is 2. We have a block scope, which is this constant, which is 2 minus 5, which is -3. Right, there it is, the -3. Right, so it's putting that in there, and then the string array. So in there we also have the constant, the number. So all these numbers and all the string, they're all concatenated, becomes one single string. Okay, which is great, right? And the reason it does that is as follows. Notice the to-do list. Right, notice that we are opening the OL and we're closing the OL. See that? And then inside, what are we printing? We're printing the array of line items. See that? Which is what? It's basically the concatenation of those two line items and replacing them right here. Right? Notice that if instead, notice that they render as expected. See that? 2 line items, and they're correctly numbered. If instead it would have rendered the square brackets and the commas and all that, we would have had to write more code to strip that out, right? Because this is a common thing that we want to do, right? We want to iterate over HTML content, right, and just display content without having to worry about stripping out extra characters and whatnot. So it's very, very convenient that React, the way it renders the arrays is that it concatenates everything, which works wonders. Okay. And manipulating arrays, yeah. So to manipulate arrays, you can use push, pop, right? You can splice things. You can add new items, remove items, right? So let me just illustrate real quick, just a few couple of examples. All right. So yeah, for instance, here we have a couple of arrays, a couple of to-do items, right? And notice that by push allows me to append at the end of the array, an item. So this becomes 1, 2, 3, 4, 5, 6, right? Here I'm pushing another one, 3, so it becomes string 1, 2, 3, 1, 2, 3. And here I'm pushing a new HTML item to the array, right? And then, so not only can you add, but you can also splice. So splice allows you to, actually splice allows you to do both. It allows you to remove and also allows you to add, right? But more commonly, it's for removal. So splice here, you can say what index do you want to remove and then how many items you want to remove. So here's from number array, item number 2, so 0, 1, 2, right? We want to remove the 3. So it becomes just 1, 2, 4, 5, right? And here we're removing at index 1 in the string, so 0, 1. So we remove the string 2, right? And we're left with string 1, string 3, right? And then we display all that. So the map functions, it's pretty cool. Let me show you that. So the map function is going to be your best new friend. Okay. So here we have the map function being used to compute things such as the square. Notice that we're declaring a new function. Here is being declared, and then map. We're passing the function inside. I mean, we could have embedded this. We would have copied this and put it in here. That would have worked just the same way. But if you're going to use the square function multiple times in different places, then it makes sense to declare the function, right, and then use it in a whole bunch of places. Now, if this function, the only place where this function is ever going to be used is here, then it makes no sense to declare it, right? Just waste a really good name, a variable name, right? You could just embed it in here. Obviously, if the function is really, really big, then maybe it does make sense to declare it, elsewhere and then put it in here, right? Anyway, so here we're using map, right, for calculating all sorts of just arithmetic values, right? Squares and cubes. So here we have the squares, here we have the cubes. But actually, what we're going to be using it for is for this, right? We're going to iterate. We're going to embed, right, inside, right, our code snippet, right? We're going to iterate over the of the items of the to-dos, for instance, of some array, and then as we have each one of the items, right, we're going to calculate the HTML, right, on the fly, right? So we're iterating over the array. The array could be some complex object, right, with a whole bunch of properties and blah blah blah, right? It could be, instead of the to-do being just strings, it could be objects that have, whether it's completed or not, when is it due, who's is it assigned to, right? Whether the priority. And so it could have, each object could have a whole bunch of properties, right? And as you're iterating, right, you can then render a very complex HTML, right, with checkboxes and and date drop downs and user drop downs, right? So based on this object, right? And basically, that's what React is. React is algorithms that convert some data type, some data structure, some data represented in any which way you want, converts it into some equivalent user interface. Basically, that's all React is, right? React is, hey, I have some data, implemented in some JSON representation, right? And I, give it to the main, app function, the top level function in React, right? And then it returns to me as a response, right, all the HTML that is going to be used to render something visual on the screen, right? So that's all React is, right? Is a function that calls other functions, that calls other functions, right? That breaks up the work of multiple data structures, and it computes the resulting user interface that is going to render on the screen. That's all React is. It's a transformation function, transforms data into user interface. Yes? Okay. All right, so let's talk about objects. As I mentioned earlier, right, the JSON is a very popular way to format data, right? You can literally create an object very easily just with a square, curly bracket, dump a whole bunch of properties in there and give it the values, and you can mix and match multiple data types inside of a single object. Here's an example of declaring a house that has bedrooms and bathrooms and has an address. So it's an object embedded in another, instead of another object that has its own properties of street, city, right, state, and then the owners as an array, right? So let me illustrate in where we declare first a house constant, right? It has all these properties, and then we're going to render again the transformation function. It's going to convert the user interface equivalent of that object, right? So we're going to render the bedrooms, the bathrooms, right? And let's talk about this pray, right? Very, very interesting. This utility function, right, called stringify, that is declared inside of this JSON object. So JSON is a global object, right, that is available in all browsers, well, in all Node implementations, right? That basically gives you a several utility functions that allow you to convert back and forth either objects into their string representation or vice versa. From string representation, it'll parse it and it'll give you a JSON object instance, right? It can go vice versa. There's stringify and there's parse. So stringify takes an object, right? And then returns a string representation of that, right? And we're formatting it with 2 characters, right? To the tabs. So it adds the new lines, the tabs, and then we're pre-formatting it so that it renders with this these monospaced character, right? That they're all the same size, right? So that it looks nice and neat. Right? So this is actually a very useful debugging tool. As you're working through problems and it's not working correctly, just throw in a JSON stringify like this, right? So yeah, you can see the actual data, right there, render right on the screen. It's a great debugging tool, right? As you're working through, it says, well, why is it not rendering correctly? What am I missing here? Whatnot? You can see the actual data structure, and then you can just say, oh yeah, so the address is spelled with 2 S's or something, right? And you were misspelling it something here, right? So yeah, so it's a very useful debugging tool. Definitely use that. Okay, I encourage you to use that.